Hi, Year 11. Today we're going to be looking at the kinetic energy of moving objects. If you haven't had a chance to do the do now already, please pause the video, go back to the packet and have a go. Okay, so now you've had a chance to look at these, let's go through them. So the store of energy that increases when an object is projected upwards, that is gravitational potential energy because you're gaining height. What changes in energy stores occur when a moving object hits an obstacle? So we're starting off with a moving object, so that's got to have a kinetic energy. And when it hits an obstacle, it's going to stop, so that kinetic energy is going to be transferred to a different store. It will increase the temperature of the object it hits and the object itself. So that will increase the internal energy store of both the object and the obstacle. You will also get some sound energy. What energy store increases when an object is accelerated by a constant force? An acceleration is an increase or a decrease in velocity, so we'll assume it's an increase this time, so the answer to number 3 is kinetic energy. What changes in energy stores occur when a vehicle is slowing down? So again, we're starting with our kinetic energy store. That's going to decrease, and the stores that increase will be primarily the internal energy of the brakes. So the brakes transfer kinetic energy to internal energy, so they increase their temperature. And what changes in energy stores occur when a kettle full of water is boiled? So you have electrical energy transferred to kinetic energy. We'll take a look at our direct instruction next. So we're zooming in today on one form of energy in particular. So this is kinetic energy, and kinetic energy is is the energy that an object has due to its velocity. So if it's stationary, it has 0 kinetic energy. If it's travelling very, very fast, it has a lot of kinetic energy. Now we can calculate that using the equation. Oops, that is not what I wanted to do. Apologies. We can calculate that using the equation kinetic energy equals 1/2 times the mass in kilograms times by the speed of the object squared. And the speed needs to be in meters per second. Kinetic energy will be in joules. So 1/2 times its mass times its speed squared. So you can see this square thing here makes it quite interesting. If you were to double the mass, that would increase the kinetic energy twofold. You'll just double the kinetic energy. However, because this is squared, an increase in speed will give you a really, really big increase in the kinetic energy. If you double speed, you increase kinetic energy by a factor of 4. You can also write this more simply with an E and a little subscript k equals 0.5 times mass times, and we'll use the symbol V for speed, so velocity for speed here, and that's squared again. Points to mention, so you can use a KE, a capital K, capital E, or a capital E with a lowercase k. And your kinetic energy is going to be measured in joules, which gets the symbol capital J. Mass is measured in kilograms, and the velocity, the speed, is measured in meters per second. We need to be able to recall these, so we have to be able to remember these in the exam. They might not be given to us. Another interesting note to think about is this mass in kilograms. So they might try and catch you out by giving you the mass in grams. We want it in kilograms, or in some instances they might even give it to you in tons. So there are 1,000 grams in a kilogram and 1,000 kilograms in a ton. So if we want to convert between them, we need to be either multiplying or dividing by a factor of 1,000. So if you want to go from tons to kilograms, we times it by 1,000. So 2 tons would be 2 times 1,000 to 2,000 kilograms. And if we're going from kilograms to grams, again, that's multiplied by a factor of 1,000. And if we're going the other way, we just divide. So we're doing the opposite. So if we have 900 grams, divide that by 1,000, gives us 0.9 kilograms. And we do the same with tons. So we might refer back to this throughout the course of today's lesson. Let's have a look at an example in context. So we have a cyclist here. This, I believe, is Chris Froome. Now, Chris Froome has a mass of 68 kilograms. His bike weighs about 9 kilograms. So the combined mass of the bike and the rider is going to be 77 kilograms. And if he's on a good day, his speed in his time trial is going to be about 15 meters per second. And what we're interested in now is that kinetic energy. So I don't know what the kinetic energy is yet. That's what I'm going to calculate. So I'm using just a question mark to denote that. We'll go underneath, and the first thing we always have to do is always write the equation that we're going to use. So a half times mass times speed velocity squared. So that's my equation. That might get me 1 mark because we do have to recall it. I will put my equal sign directly below the one above, and I'm going to substitute in my values. So equation, substitute. So 0.5 a half times the mass, which was 77 kilograms, which we saw above, and the speed was 15 meters per second, and that needs to be squared. Don't try and do this in your head, type it into a calculator. So 0.5 times 77 times 15 squared gives me 8,662.5. I'm going to write that with all the significant figures the calculator gives me first. And don't forget, it's a capital J for joules. If I were to use a lowercase j, I would lose the unit mark, so that's not the correct units. And I'm going to round that to 8,700 joules. So notice that I've done it to 2 significant figures, mainly because up here, that's 2 significant figures, up here, that's 2 significant figures. You won't be judged on significant figures unless it tells you in the question, so don't worry too much about that. Okay. So your first task is to have a go at all these. We'll walk through one more question together and then we'll see how we do. So I have a toy car with a mass of 450 grams and a Lego man of 30 grams. So the first problem is there's 2 items. So I might have to add these 2 together because it's looking for kinetic energy of both of them. So 450 plus 30 gives me 480 grams. Okay, not too bad so far, but I've got it in grams, not kilograms. So if we went back to our direct instruction, we can see if we're going from grams to kilograms, I need to divide by 1,000. So I would divide that by 1,000, and that would give me 0.48 kilograms, and then it gives me a velocity of 25 centimeters per second. So it's trying to catch me out again, but I know there's 100 centimeters in 1 meter, so I just need to divide this by 100, and that gives me 0.25 meters per second. So now I've got all those nasty bits out of the way, I can actually answer the question. So the first thing I have to do every time, and you have to write this every time, I'll write my equation. EK equals 0.5 times mass times velocity squared. Be careful not to put in the 450 or the 30. We need to use this number, this mass in kilograms we calculated previously. So 0.5 times 0.48 times by 0.25, and we must remember that it's a squared. It's really easy to forget that square. So 0.5 times 0.48 times 0.25 squared. I've typed that into my calculator and the answer I get is 0.015. And it is joules. This is two significant figures, and that matches with what I had in the question, so I'm happy at leaving it with two significant figures. Okay, so have a go at these questions. They all follow the same pattern, so we're all just going to be using the equation EK equals 0.5 times m times v squared. Use a calculator where you need to. This last question, it's going to try and catch you out. Remember, there are 1,000 meters in a kilometer, and there are 1,000 kilograms in a ton. Okay, and the next task is slightly more complicated still. We need to do a rearrangement before we can do anything else. So remember, we've got the equation kinetic energy is 0.5 times m times v squared, and the question is actually asking us to work out velocity. So we need to do a bit of rearranging. We need to bring everything that's on this right hand side of the equation over to the other side and just leave this v on its own. So to do that, I'm going to divide both sides by 0.5 times m. So this will give me kinetic energy over 0.5 times mass is equal to v squared. So all I need to do now is square root both sides. If I square root this side, I need to draw something like that, and if I square root a square number, it gets rid of the square. So I can be a little bit clever here. I can just get rid of the square and the square root, and it leaves me with v. So this is the equation I need to use now. So to calculate velocity, I just do the kinetic energy divided by 0.5 times the mass, all square rooted. It looks complicated, but we'll be fine if we use our calculators. So I'm going to try and write v equals the square root of kinetic energy over 0.5 times m. Let's substitute in the values. So it's going to be the square root of the kinetic energy, which was 493,900. So just this value up here, and that's divided by 0.5 times 5,040. So be very careful about typing this into your calculator. So square root 493,900 over 0.5 times 5040. Press equals, and that gives me 13.99. So I'm kind of breaking a maths rule here. I'm putting an equals over here, but really it should be underneath, but I've run out of space, so I've not thought that very well through. That comes out as 13.9997, so I'm just going to round that to 14 meters per second. So 14 meters per second. Okay, you guys have a go at this one, see how we do, and then we'll move on to the next set of questions. And the last sort of thing we might have to do is rearrange to make mass the subject. So again, we're going to start off with the equation kinetic energy is 0.5 times mass times velocity squared. This time I need to have m on its own for mass, so I'm going to divide this side by 0.5 V2, and that should give me mass is equal to the kinetic energy divided by 0.5 times V squared. As always, write the equation. So kinetic energy over 0.5 V squared, and our kinetic energy in this instance is 1.6 divided by 0.5 times 0.2 squared. Now again, just got to be super careful when typing this into the calculator. So 1.6 divided by 0.5 times 0.2 squared, press equals, and that gives me 80 kilograms. So make sure you don't forget to put this squared, that's really important, really easy to miss that one off. Okay, you have a go before moving on to the next page. And finally, so your independent practice here, it says a car and its passengers has a mass of 1,200 kilograms. It's travelling at 12 meters per second. Calculate the increase in kinetic energy when the car increases its speed to 18 meters per second. So for this, you really need to show every step of your working. Okay, I cannot state this enough. You have to show all your working. You need to then write the correct equation. You need to calculate the kinetic energy at 12 meters per second. You then calculate the kinetic energy at 18 meters per second, and then you do the final kinetic energy minus the initial kinetic energy, giving the correct unit with your answer. Okay, best of luck. Thank you very much.